Everybody is cleaning. If you think about what do you do every day, I'll suggest you might wash, you might clean your teeth, and you probably clean in the kitchen. So it underpins all sorts of operations. If it's difficult to do, then you need to understand why is it difficult? Why doesn't it want to come off that surface? What we tend to do is we will do some experiments or do some observations and make an assumption about the nature of the material and then say, right, what's the best way or the quickest way or nowadays the most sustainable way of getting that material off the surface to a place you want it to be. Well, this is an existential question, and it depends how clean do you need it to be. In a food factory, it has to be what you might say microbially clean. And if you're working in the semiconductor industry, then clean is really clean because your surface of your microchip fabrication, etc., has to be free from all contamination. We are trying to build up a scientific understanding of cleaning processes. And I'm just really interested in how this underpins a whole lot of everyday life. So we have a collaboration with a company that makes heat pumps. When they're using hard water, things stick to the surfaces, and this is not good for heat transfer. Another project is with a company who make lots of aseptic processing machines, and they want to understand how well they could predict the cleaning using these flows. And so that is mostly developing computational methods for describing how things remove. And then the rheology work is related to a project with a problem in the eye, where if you have a retinal tear in the eye, the treatment that's used for that sometimes gives rise to emulsions forming, which is not good, okay, because it's very difficult to look through an emulsion. The wonderful thing about Cambridge as a place and the department as well, you have lots of people working in different areas, and where you find an overlap between those areas, you often find an opportunity for new work or discoveries, or actually explaining some of the observations that colleagues have, or my colleagues can explain to me why we're seeing this, because they're doing something related but in a completely different field, which usually means with different language. I'm an experimentalist, I work with people. So the people who work with me and the people who graduate from our research group, etc., they go on to do things. We're training future generations of researchers, of academics, of engineers, etc., to go on and do things.